Welcome everyone to the very first virtual Nova Software Quality Engineering and Automation Meetup. My name is Jonathan Kaufman, and I work for a company called Coveros, who helps organize and run this meetup. This session, or this meetup, is normally hosted at Fannie Mae's office in Reston, although obviously we're not doing that right now. So I appreciate everybody working with us through this time and trying out GoToMeeting as a platform for continuing the knowledge sharing that we like to provide as part of these meetups. As you can see in GoToMeeting, there is a chat system you can use to post messages. I would encourage you to utilize that during the session if there are questions that come up. I'll try to monitor that, and if there's something I think is urgent, maybe break in, but we will definitely have time at the end for questions if there are things you want to ask our speaker. Something else I want to go over as a housekeeping item before we start is it would be great. I'm about to paste a link to a sign-in sheet into the chat. It links to a Google Doc. So if you have a minute during the session, it'd be great if you could sign in, provide your name and email, and then also whether or not you want to receive information from Coveros. Totally up to you what you want to do there. And then another note is that this meetup is always looking for new speakers. And given our typical quarterly cadence, we're looking for a speaker in the August timeframe. Although given that we're doing this virtually in the near future, I'm sure we'd be open to something sooner if you have a talk you urgently want to give. So if you have talk ideas either way, just reach out to me and I'll work with you to figure out when we can host a talk for you. And then one final item before we start is I wanted to mention some upcoming events that Coveros is advertising. I was going to paste in the chat, but that doesn't seem to be working. Let me try one more time, and if not, I'll just speak to them. Okay, that's not working. All right, well, I'll just speak to this. So one is the lessons learned designing tests for CI/CD webinar that is going to take place on Thursday, May 28th from 1:30 to 2:30. So for some reason, pasting doesn't work. Okay, and then the second thing I wanted to let you know about is the Agile DevOps Virtual Conference. It's typically an in-person conference out west in Vegas, but we're hosting it virtually. And you don't need to pay to attend. There are free options as well, in addition to the all access pass you can pay for. So please check that out. And then I don't think I have anything else, so I'm just gonna go right into the talk itself. So today we are going to hear from Simon Bohr, who has over 15 years of experience working for the British government and international organizations, who is currently the head of products at Inflectra. He likes solving user experience problems, designing cool stickers and decals that you would normally be able to get if you're at an in-person meetup, and he also likes fixing bugs. With that, I'm going to turn things over to Simon, who will teach us about some of the experiences he's had in the testing Twilight zone. Simon?
Thanks so much, Jonathan, and hi everybody. Thanks so much for being here. Hopefully you can see the slides on my screen, and if you really want to, you can also see my webcam, but I believe you can turn that off if you don't want to, and that's fine by me. Hopefully my audio is okay. If there are any big AV problems, I guess, put it in the chat and Jonathan will try and help out. So welcome to the Testing Twilight Zone. As Jonathan said, I'm Simon. I'm the head of products at Inflectra, which is a local software company based just in Silver Spring, Maryland, outside of DC. We make test management software and test automation software. My background is not as a tester, though I do quite a lot of QA. I'm not great at finding bugs. I'm okay at finding bugs. I probably enjoy, as Jonathan said, I enjoy fixing bugs more. So my experience I want to share with you tonight is not from me as a tester, but more from me being somebody who's worked in a company that makes testing software and seeing the extremes that people go to in their testing while using our tools. So I've spoken to our support team, some of our engineers, to collect a bunch of strange anecdotes and examples of how our customers try to get their work done. Of course, this is, they only get in touch with us when things work. They don't get in touch with us sorry, they only get in touch with us when things don't work. When they do work, they don't call us. So there may be a whole bunch of super extreme things that I'm not exposed to because I only see the weird things that they do when they contact us and report a problem. So like I said, in Inflectra, we make agile planning, tracking, testing tools. And our two flagship tools are SpiroPlan and Rapise. SpiroPlan, the one on the left, and Rapise, the one on the right. One does manual testing, as well as things like releases and requirements and bug tracking. That's SpiroPlan. Rapise is a test automation tool for testing the web or desktop apps or APIs or mobile. My anecdotes are focused around the use of those two tools. It's just because that's what I've been exposed to working at Inflectra in my current role. You don't need to know anything about those tools. I'm not going to get into describing them in detail. They're just, a points I mentioned. Oh, when using Rapise, we found this thing out. I'm going to keep this pretty lighthearted. It's my first time doing this talk. It's, as Jonathan said, it's the first time this group has had a virtual meetup. So it's going to be, hopefully pretty easygoing. I'm going to try and draw out some themes and hopefully some testing lessons for us. And at the end, I do hope there'll be time for either questions or for people to share their testing extremes. I'm sure you all have amazing examples that you can share about things that are way more wacky than the things I'm going to share with you today. So I want to share both a mix of things that go, not so well, because I think we can learn from failure. So, when testing fails or when testing goes to the extreme and people doing things not quite right, I'm not going to judge, but definitely some of the stories I'm going to share with you tonight are people doing the wrong things. So I might actually be judging after all. But they also successes, of course, and people can do some amazing things. Some of them instructive, some of them inspiring. And I hope to mix up the anecdotes of things not to do with some things to at least attempt to do, even if they're physically impossible. Every time I watch this clip, I have no idea how this works. But I think there is a conveyor belt that she's being moved along. You can see a little line behind her feet. I said I've watched this like 50 times. So moving on to actually some of our real examples. I'm going to take this in phases. So it's kind of all chapters, I guess, for each of these. And chapter 1 is about, the classic line, at least as every developer, I'm sure, has said this, and every tester has heard it said to them. Well, it works fine for me. It's a classic, sure. But I want to start off with a couple of examples to talk about, in particular, how to deal with this when you have this on an test automation side, where things can get really tricky trying to diagnose the problems. So the first example I want to share with you is when, this again, someone was using our tool Rapise, and it was a major publishing company, and they just started to use it. And we'd work with them, as we often do when someone's just starting a tool with us. So I had this like technical training support session with them to help them get an example script working on their system. So we do that, remotely. We work out their needs just for a really simple test of whatever this publisher was looking to do, and we generated the test and then sent them the final test so they could, get started on the road to being successful. The problem was, as soon as the client said they tried to run the test, it didn't work. It was a complete fail, spat out a load of errors, and just didn't work at all. And obviously they weren't happy. So we tried to, troubleshoot through all the potential problems that it could have been. Was it to do with the installation she had? No, she was using the correct version of the application. Was it to do with the environment? No, the environment looked good. Hardware, browser plugins, you name it, everything we went through wasn't the problem. So we did a screen share with our automation engineer, was looking at her screen. Obviously, it's kind of like probably you're seeing now, a little bit blurry, but everything looked good. The application was running, the test was there, click go, complete failure. So eventually, I don't know, for some reason, the automation engineer said, well, just send us the script that you're using. Even though it looked like the script when they could do the screen share, so just send us what you're using. Maybe they changed something in it, they'd rewritten the script. So they sent it through, and the engineer opened it up in the code editor. And if you looked at it quickly, everything seemed fine. The function names were the same and all of that stuff. But it turned out that there were smart quotes instead of plain text ones. So smart quotes is what, the one with a curly brace going, that one way versus the other, as you see in a normal book. But of course, a computer doesn't know how to deal with that. It's not completely plain text. So as the computer tried to pass this special character, it just failed. It's kind of like putting an emoji, I guess. inside your test script. So the issue, of course, here was the client, who was actually an editor at this publishing company, had done what she always did every time someone sent her a script. In this case, it happened to be a script in code in JavaScript rather than a manuscript, but made no difference to her. She opened it up in Microsoft Word and went through looking for typos and formatting problems. Thankfully, she knew not to change function names, and she kept things in camel case, but she went through and automatically fixed the quotation marks, fixed indentation, which we use JavaScript, so indentation isn't a problem, but if it was Python, for instance, indentation would have completely ruined the code even more. So she did it. She made the changes perfectly in accordance with her years of publishing and all that experience in publishing. But of course, that's not how code works. So of course, it's an easy fix. We could just tell her what to do. But it's really interesting to think about how somebody can take something that looks fine and try and adapt it for their own needs and actually get things a little bit wrong. But what happens when it's not the script that's at fault, but maybe something else that's going on? So we had a case again with another Rapise client. The test looked perfect, and the client confirmed the test was working perfectly anytime the engineer ran it in their test environment. But when they were testing it for real, against their real application under test and in their proper environment, like in their automated way, the test just kept failing. But it didn't fail all the time, and it didn't fail at the same point every time. It would fail at random ways, and no one could work out why. So sometimes, the first step would fail, sometimes the third step, sometimes the last step, and there was just no logic to it at all. So again, it goes through all the things. Is it the test? No, the test was definitely working this time because it worked on the engineer in the company, not our engineer, the client's side. It worked for them. The environment, well, they're actually connecting over an RDP. So the actual test, the application environment should have been the same because they were just logging into this different environment. So, okay, it's not the software, it's not the script. Could it be the hardware? Or could it be ghosts? So we asked the customer to go to the machine where it's running, check the actual machine, run the test, and see what happens. And guess what? Everything passed. Okay, so it's not the software, it's not the test, it's not the hardware. So basically, we're left with ghosts at this point. And the problem in the end was kind of similar. It ended up being a kind of poltergeist. We looked through all the automation engineers looked through all the log files and could see that sometimes the cursor was not where it's supposed to be. So obviously the cursor's moving because we're controlling the automation. The cursor should go here and click this button. But sometimes it just suddenly moved and was not where it should be to click the button. What moves the cursor? Well, the automation tool does, but also, of course, the mouse moves the cursor. Now, no one should have been touching the computer or using it, but apparently it was set up in such a place that people walked past it or, blew on the computer or something, which touched the mouse, which I think reset the screensaver, which recentered the mouse, which screwed up the test. So the solution ended up being perfect and incredibly low tech. Just run the test on a machine that lived in a room by itself that no one would touch. They ended up working out fine for them. So I want to move on to chapter 2, when things are clearly not what you should do. The cases before were examples where, okay, we don't know what's going on, but we can fix it. And here are cases where we do know what's going on, and you just probably shouldn't work that way. There are some little lessons here, but each one I think is self-enclosed. Just don't do that. We see this a lot. A lot of our customers just try to test too much. We design our manual testing tool, which is built into SpiroPlan, our test management tool, to be tested by humans. And we assume that a single test is something that a person or maybe a small team, maybe they do it in a day or a couple of hours or maybe a couple of days. Certainly for us, when we're designing our tests, we assume they're one testing session. I think the biggest one that our team does is maybe half a day for some very complicated tests all connected to each other. But if it's bigger than that, we break up the test, or we break up how to test it. So it could be done in different chunks, which helps our reporting, as well as helps our sanity. But not all our customers think this way. We have, well, when we're in the office, we had a dedicated whiteboard which had examples of where our customers had thrown caution to the wind, where they said no test was too big, no number of test steps in their test too high. And as of a couple of months back, when we were still in the office, the maximum number we had seen was 3,500 test steps in a single test. So this is, a normal step in our application is, log in, click this button, can you save a new field? That would be a step, and they have 3,500 of them. And that's for a human to do, or maybe humans to do, I hope, just basically all at once. Over the course of, we expect, a couple of months. And they were complaining to us. That's the only reason we saw this in the first place, was because they were complaining about the performance in our application when loading 3,500 tests at once. They were complaining the performance was slow. So the only response to this is kind of like that old joke about the lady who goes to the doctor and says it hurts when she raises her arm, and the doctor just tells her not to do it. See, normally you don't want to tell your customers not to do something, but here we really say, this is not how humans are designed to test. If you want to give a machine 3,500 tests, that's fine, but for a human, please just give them something a bit more sane and manageable. Sometimes when you're making tests, you do realize there's a bug in the test, not the code. So you have to change the test. But for some people, by people I'm actually specifically talking about, this is the shocking thing when we hear about these things from hospitals, or a particular hospital customer of ours and a federal regulator we work with, who want to take it further when they discover a problem in their test. I'm sure they don't mean to actually fake things, but you can decide for yourself. For us, it kind of feels a little bit on the slippery slope side. So we were explaining a cool feature that we have to this regulator. We have this exploratory testing mode. So you can run your manual tests in the application. You start with your test, you execute it, and then you can change your test while you're executing it. And this is designed specifically for senior testers, exploratory testers. I'm sure that's many of you here. So that you know what you're doing and you can build up the test as you're testing it. It's not to fake or change results. It's just you want to have a good record of what you've done, kind of like if you're using screen capture software to capture your testing session. The regulator was super excited when they saw this, not because they had lots of exploratory testers, but because they wanted every single one of their testers to run every single one of their tests in this mode, including regression tests, so that every time they ran it, if they wanted to, the tester could just change the results whenever they want. This is for a regulator creating, their software to manage their regulatory environment. That's something we did not encourage them to use it in that way. Whether they are or not, I actually have no idea. They haven't complained about it to us yet, so I can't say. And in a similar vein, the hospital customer of ours realized that after a round of testing, they'd made a mistake during the test, and that's why they contacted us. They wanted to know how they could change the results after the fact. Our tool doesn't really let them do that, but we said, you could just rerun the test. And if you need to pass everything, then you can just hit pass on every step, or there's a big pass all button we have. And they said, well, that doesn't really work because we have thousands of steps that we want to change the results for all at once. And we have other clients who just say, I just want to delete all the test data because I need to create a report and I need the results to look this way, not that way. Can you please show me how to delete the test results? And we politely say, no, we can't, because we didn't design a tool that lets you easily, or sometimes a tool, delete any of the tests. Like, I think it's a good thing to have data integrity in your testing and have manual tests that aren't flaky, like some unit tests can be if they, depends on the phase of moon or the time of day. If you have a manual test that's run and it's passed, you can rely on that result being accurate, not questioning whether it's only a pass because someone has doctored the result in some way. It just seems like a very bad slippery slope. So chapter 3 I want to talk about next kind of takes the opposite approach. Rather than being a bit loosey-goosey with how you do your testing, how to be very, very precise. Now, when we make tests for testing our own tools at Inflectra, we try and design them carefully, and we try and have clear testing charters when we have exploratory testing sessions. But sometimes that just isn't enough, and you need to go one step further, or sometimes more than one step further. So this first example, talk about hardware, particularly microchips. And we all know that making hardware is very different from software. Software, many of us either live in or have daydreams of living in a continuous integration, continuous deployment scenario where maybe we can release multiple times a day. or at least we can get a patch to somebody quickly. So we at Inflectra released a new version of our software at the weekend, and we found a bug, like a day zero bug, that affected a really small number of customers, but we still in half a day could diagnose, implement a fix, test the fix, and then deploy all quick. We don't normally work that way. We don't like to. We normally release every couple of months, but we can if we wanted to. Hardware, yep, completely different. But what about the software that's used to make the hardware? Well, a customer of ours was using our software to test their software that they use to design microchips. So if our software works, then that it can determine that their software is working. And if their software is working, then their simulated chip that they use to check whether the chip in real life would work, then that means if the simulated chip works, then the real chip works. And if their software tells them the simulated chip works, then they can go into production. And of course, if there's a mistake, then they lose 4 months of work on the prefab line for the chips, and obviously a whole lot of money. So while that's not, we don't make hardware at Inflectra, and maybe many of you or maybe none of you make hardware, I'm sure many of you face similar issues where even if your direct clients, your direct customers are not doing things that are that significant, your indirect customers. So for us, our indirect customer was testing a piece of software that tested effectively a piece of hardware. So indirectly, we still take that quite seriously. It does affect how we think about quality as a company, just to think about the impact that we can have. But the impact goes further than just chips and money. It can, of course, be more serious for more serious scenarios like power stations, medical device manufacturers, or airlines, all of which have to validate their software. I don't know if any of you are from regulated industries, but for all these sectors, they have to be super careful before they start using new software, or even if they can upgrade new software. So, if our test management tool says a certain test passes, or if they're ready to release, can they trust our tool that it's giving them the correct answer? So before these customers can test using our tools, they have to test our testing tools. And the same when they upgrade. So they can't upgrade until our testing tool has gone through a rigorous validation exercise to determine, yes, this testing tool has passed all the tests it needs to test. The question I have for them is, well, what are they using to test the testing tool? Well, I think what they're using is they're using an earlier version. So if they validated version 6 of our tool and they want to go to 6.2 of our tool, then they can use version 6 to test 6.2 to run all their tests and record the results, and then I presume then they can do the upgrade safely. So that's one way. So this is a customer taking it on themselves to determine whether our tool is good enough. But there are other approaches too. So if you look at another regulator, federal regulator, what do they do if they're buying software for mission critical work? Well, they do take a different approach. It's just one regulator to the power station. The power station, they buy the tool from us, they validate it themselves. We write the software as Inflectra, we run the tests that we think need to be run before we release, we fix things, repeat, 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 and then we can decide to release. And it's the client decides whether they're happy to do the upgrade, whether they're happy with the quality of our tool to continue using it. But for a regulator, in this case, it was for software for air traffic controllers, the software manufacturer had to convince the regulator that their software is good enough for them to use in air traffic control situations. So what do? The regulator does not take the software manufacturer's word for it. In fact, each and every test case has to be approved by the client, by the regulator, before it can even be run. So you have a scenario of the software manufacturer going to their customer, presenting them all the tests they're going to run against the new version of their tool, and all those tests have signed off before testing can even start. Then the regulator, the aviation regulator, has to physically watch every test the company manually executes. So for each and every test that's run, you have, I don't know whether they're using an iPad or a piece of paper or something, but there is physically the person at the machine doing the test, the tester. Then there's the watcher of the tester who is observing them doing the test and making sure they're doing what the test says they should do. Do you think there could be a less manual way of doing this? This is obviously what either the law requires or what the internal policies of the regulator requires. But you think at least there could be a better way to communicate this, maybe screenshots of test results, but this is what they have to do. This brings me on to the chapter 4, communication is key. I'm not going to talk about testers and developers and how we as product teams work together. A colleague of mine in Inflectra did a talk, I think it was in Europe last year, about how testers and developers communicate and miscommunicate with each other. But I'm not going to talk about that. I want to talk about how different parts of so we had an automation client called Sarah, and she was trying to get her test working, and one of our automation guys, Dennis, was trying to help her remotely. The problem was that as she was building up the test, the first time you make an automation test, or this is what the team often tells me, like you want to build your test so that it fails, because then you can then fix it and then finally get it working with all the different parameters, get all your logic correct, get your XPath right, make sure it's all robust. So Sarah's building out this test so that it fails, so that she can then refine it. But the problem was the errors weren't being logged in the useful way to her on her screen. They were being logged on a remote server when she did something bad in the application on the test. But Sarah didn't have access to that server. Sarah had to call a department to request the log file be sent to her. And then later in the day, someone would get round to that task and would find the log file, email it to Sarah, or they email it to somebody else, who would then email it to Sarah, who would then forward it to my colleague, Dennis. And this happened every single time. We had to go through the iterating, working out, is it the piece, our tool at fault? Is it that she's not understanding how the piece works? Is there an issue with the test itself? And this troubleshooting, well, I've got this picture here, reminded me when Dennis was telling me of kind of the punch card era. Like you've got to, Sarah had to think so carefully, or ended up thinking so carefully about how to design a test, because it's like when you're writing a program and going up to one of these ancient punch card machines, you've only got one chance. You've got your 10 minutes at the machine. You've got your pile of punch cards. They have to work. It has to go in. It has to be correct first time. So bureaucracy is not quite as costly as ruining a prefab process for a chip, but it can still be pretty painful. And it does definitely make us all think about how we can build our test to be a bit more resilient, and maybe, like I said at the beginning, cutting twice or more to sort of measuring twice or more, so we only have to cut once. We don't have to rerun the test for multiple failures. But sometimes it can be really hard to, even when everyone is an expert and even when everyone knows what they're doing, to actually design a test that works in the way you want it to. So we were working with a medical expert. It's a company that makes medical record keeping software. And they had a spreadsheet of data that they were using to plug into our tool to then, carry out the tests of the recording all the different medical records. And a specific example they're getting stuck on was the temperature field. Now they're recording temperature in, let's just say it was only in Fahrenheit, not potentially in Celsius. So recording in degrees Fahrenheit, which is a number, a decimal, probably with only 1, maybe 2 decimal places. So to an automation engineer, that seems very straightforward. Okay, we have the field temperature, body temperature, and it must be a number field with this degree of specificity, this number of decimal places. So it seemed pretty obvious to the automation experts. But to the clinical expert, to the medical experts who were trying to get this tool to see whether it would work for real life, they weren't sending in decimals. They were sending in word. They were sending in spaces in between the, say, 98.6 would be 98 space 6, or 98.6, or 986, or 98,6, which is how you do decimal points in Europe and elsewhere. And they didn't do this on purpose. They just wrote it. They didn't particularly care about the integrity of the data. So our automation engineer gets the spreadsheet, sees the problem, their eyes roll, like, oh, this is terrible. I've got to make it precise. So they do the data cleansing on behalf of the client. The client doesn't, I'm sure, know what data cleansing is, and then gives it back to them to rerun the test. And then they run into a problem. This time, not because this time it's the fault of the automation engineer, because it turns out, well, yeah, normally we want this field to only be a decimal, but I don't know why this is the case, but for young children, they needed to record the temperature simply as high or low, either as a text field or as a dropdown. So they needed to, we didn't understand the application, but they understood the application and necessities of the medical world. And trying to get these two experts to talk the same language was incredibly difficult, because one spoke medicine, which was precise but sometimes imprecise, and obviously there's a lot of gray area around determining what the correct answer should be from the health perspective, and the automation engineer, who's much more cut and dry, much more the spreadsheet must have, this must be a number field. And we see this outside of testing specifically, but we see this as a support team, which I work with all the time. It can be any kind of semantic issue, people referring to the home page, and we call it the home page, they call it the hub, or they say my task list. They say my task list does not load. And we have to say, well, can you send a screenshot? Because we have no idea. You could be talking about the task page, the list page, the home page, all these sorts of pages. We have one customer who said that they wanted to select none for a dropdown, and they couldn't see none as an option. So you don't select none, you select, select nothing. And they said, but nothing isn't there. What do you mean select nothing? I was like, no, literally the bit where there's a space, where there's white space, go there and select that. And it took like 3 different goes to explain to this customer what nothing meant. So it was a very metaphysical discussion on the nature of reality and nothingness. And that was, speaks to the issue of how to verify bugs, how to solve bugs, working with customers to try and just understand language. And I think it's particularly important now with us being remote. I oftentimes we use chat at work. Oftentimes just try and write a very precise sentence, which I'm sure no one can misinterpret. I even put a smiley face at the end. But it doesn't mean that someone's going to actually understand it. And actually, it's like with this customer who couldn't understand the nature of nothingness. If we had just probably had a screen share with her, could have taken no time at all to explain, like, oh, when you use this term, what I mean is this, here's what I'm doing on the screen. And that can often help cut down barriers, but still getting deep technical experts to understand each other often takes, I think, a non-technical expert in the middle, which is often sometimes like me, because I'm not as technical as my automation engineers. So I want to move on to chapter 5, which is got a very simple title. These aren't necessarily bad things. Some of them are pretty good. Some of them are just interesting for these final few anecdotes. And I think some of them are kind of cool. We're going to start off with the one that's my favorite. And this is a really cool idea that a customer just happened to be talking to us about while asking, again, about like was there a bug in a tool, how to use our tool properly. They run testing, and I don't know if any of you do this, but they run testing all together in a single testing blitz, either over a single day or maybe over a few days. Everyone's together in a room. Obviously now it'll be a virtual room, but everyone's together for this testing blitz. And I kind of imagine it's like a coding hackathon where everyone's testing the application, they're breaking things. If somebody finds something that's wrong, maybe they stand on the chair and shout that everyone either should pivot to test this thing because it's a hotspot, or they should definitely avoid it because it's definitely dodgy and they've logged the bug and there's no point in anybody else exploring it. It's kind of cool to think of all these people just sitting around testing together. Certainly in our testing setup, the testers have their tests and they run all their tests in parallel, but they're not kind of all working together seamlessly in a big room with pizzas and coffee and everyone cheering each other on. So it seems like a cool way of testing, but I'd certainly like us to try in the future. A key part of testing, certainly when you find a bug, is how do you report on the bug? You want to try and make the bug as easy to or the steps you've taken to identify the bug as easy to reproduce as possible. And I do some testing, but I'm more of a developer. So when I create a bug report, the reproducible step, they're really quite specific and they seem to me very logical, very abstract, and very clear. But to somebody else, even to the developers who may be used to logic and abstract things, they're often just too obtuse, or that I have 15 steps you have to go through before you can literally get to the step that failed, because I'm not an amazing tester, whereas our testers will create bug reports that far less abstract and therefore far more useful because they're much more tied down to the real world, and they can actually say, when I do this and click here, this is exactly what happens. So it's accurate, maybe more accurate than me, certainly accurate in a different way from me. We had one customer who went above and beyond when they were trying to tell us about a bug. Again, this was using the PSAL automation tool. So rather than just tell us, oh, when I try to use your tool to test this button, it breaks, which is really hard to do because if you're testing bespoke applications, which is normally why you're buying a tool like ours, then normally you're creating something bespoke. It's hard for us to reproduce it. So they sent us a ticket in support with a dedicated app. It was literally a pared down version of their whole actual application, which just had the one control in it, so nothing else, just the control. So really, just completely minimal setup for the application under test that they were trying to get the piece to work with. And they said they gave a specific script that this specific sub bit of the application was designed to test. They said, run this test against this application, and then you see the results. So that's kind of a super way to reproduce. Obviously not relevant to us necessarily, it working inside our own companies. We don't need to literally create dedicated apps to share with each other. But it's pretty cool to think about how they really took being able to document how to reproduce something in the most minimal way possible. And I remember there was one bug we had where the steps, if you do 5 different things, you could reproduce the bug, but only sometimes, because actually the specific steps were so precise, you basically had to write a mini script to say, you have to have this very specific setup and then do these very specific things. So our test report was very general, but to work out the fix was very, very specific. And if we'd had that very, very specific definition of the bug to start with, it would have saved the developers time. Obviously, would have taken the testers a lot more time to figure out what the problem was. So it's just kind of sharing information around, or sharing the burden between the testers and the developers. My final example is a bit more esoteric, but just to say that when we are looking to review why something isn't working, particularly automation, but it can be for other things, often we're working with really delicate tests. And when you're working with delicate tests, things can go wrong, as we saw before, just by breathing on the computer or touching the table. So when we try to validate what's going on with the customer, we will, from support or elsewhere, we may, we'll have a screen share, kind of like we're doing now, maybe over GoToMeeting. But the very act of our presence there can skew the results. So we've had it like everything works or doesn't work until we show up, and then the reverse happens, which of course is very infuriating to the customer. But it's not their fault. It could well be because they're now not connecting over an RDP because they are now they know they need to share their screen with us. Or we made them turn on a plugin, like a GoToMeeting plugin, so that we could see their environment. And all of these things are actually changing the environment. Now, I know that this is Schrodinger's cat, and I know that this is not really a good example for Schrodinger's cat. I just want to say, like, it probably should have been Heisenberg's uncertainty principle, and I thought I could have had a cool picture of Walter White from Breaking Bad, but basically I had this picture of this cat in a box, so I just thought I had to do Schrodinger's cat. But for anyone who's pedantic about physics, I'm pretty sure it's Heisenberg's uncertainty principle, but you can correct me if I'm wrong. Anyway, so this is a bigger issue now, maybe for distributed teams, and we are trying to verify things. So I'm not frequently screen sharing with my colleagues, and they're trying to show me their environment. And there was something today which I couldn't reproduce what my colleagues saw when we were trying to fix something. And probably in the end, we just put it down to just internet broke for a second. We're all working remotely. We're testing on a remote machine. Normally, we're testing in our own office, so the server's very close. Now we're testing remotely with slightly spotty Wi-Fi, and probably in the end, that's why momentary glitch. That's why she had the problem. So what does all this mean? We've gone through 5 different chapters. I just want to leave you with just a summary of some takeaways that I have got from hearing all these examples from my colleagues. And I just want to end by saying thank you so much for listening. I hope this was useful. If you have any questions or any examples possibly more extreme or more strange or more Twilighty than the ones I've shared, then I'd love to hear from you. So Jonathan, maybe first of all, people could put their questions in the chat, and if they have an example they'd like to talk to it, maybe put your hand up or something in the chat, and then if there are any, we could ask you to take over the mic.
Thank you, Simon. So at this time, if you have any questions, feel free to put them in the chat or any examples you want to share, and we can talk about those. Well, for the benefit of people who will be watching and listening to this later, I'm going to read some of these. One comment is, "Thank you. I particularly enjoyed the example with the smart quotes." Someone else said, "Thank you. Very entertaining." Yet another person said, "Thank you."
Well,
So
thank you all very much.
And appreciate you all coming out. Just as a reminder, we're looking for speakers as always, so please feel free to reach out to me if there are any talk ideas that you have. But thanks everyone for attending, and I hope you enjoy the rest of your evening.